Hello, everyone. Good morning. Respected authors and invited guests, welcome to the technical session 8D. Myself, Gayatri Burguda, and the session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you all to the 11th International Conference on Information and Communication Technology for Intelligent Systems, ICTIS 2026, Bangkok, Thailand. The 11th edition of the conference is being organized in a hybrid mode. The physical event is being held today in Bangkok, Thailand, and the virtual event is being held through Zoom from the 9th to the 11th of April 2026. I hope you all will enjoy the knowledgeable sessions throughout the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for the question and answers. Upon 9 minutes, I will raise a gentle reminder. Apart from that, if you have any queries or doubts, you can just text me in the chat box. And just before we start the session, I would like to introduce you all to the chair for this session. I'd like to introduce you all to Dr. Bimal Patel. He is an associate professor in the Department of Information Technology at CSBIT, Charsat University, Gujarat, India. He has published more than 23 research papers in reputed journals and international conferences. His research expertise includes Internet of Things, green IoT, wireless sensor networks, MANET, and large language models. Sir, would you like to address the participants?
I hope they have covered the. Is my voice audible, ma'am? Is my voice audible?
Yes, sir, you're audible.
I hope they have covered the latest thrust areas and all the best to them.
Thank you so much, sir. So, I'd like to move on to the presentations. I'd like to call upon the first presenter for today. Krutika Hirebasur Krishnappa ma'am to present her paper titled AI-driven secure intelligence systems for next generation cyber physical applications. Ma'am, you may start presenting.
Good morning, everyone. Give me a minute. I thought I'll be the third or the fourth author. So give me a minute. I'll present.
Yes, ma'am, sure.
Please allow me to share the slides. Are you recording the session? Yeah. Okay.
Yes, ma'am.
Yes, ma'am. Thank you so
Yes.
much. I'll make it a slideshow. Good morning, everybody. Thank you for giving me this opportunity to present our work. My name is Dr. Kritika Hirebasa Krishnappa. Today, I'll be presenting our research on the AI-driven secure intelligent systems for the next generation cyber physical applications. And Mr. Gabriel Wilson, he is my student. I mentored him on this project. And Miss Alia Salim, Dr. Gui, Nigel Gui, Dr. Trivedi, Dr. Yang, Dr. Sarkar, and Dr. Matthew Karoma. These are my colleagues. I work at Southern University and A&M College in Baton Rouge, Louisiana. So this work focuses on the improving the cybersecurity in the modern data-driven environments using the machine learning techniques. Can I turn on the video? Right.
Yes, ma'am, you
Is it?
can.
Yeah. Yes. So this work focuses on improving the cybersecurity in the modern data-driven environments using the machine learning techniques. So as the systems becomes more interconnected and intelligent, so the backend databases security becomes more critical. So in this research, we specifically address the SQL injection attacks, which are one of the most common and damaging vulnerabilities in the web applications. So our goal is not only to detect these attacks with is not only to detect these attacks with high accuracy, but also to deploy the system in the real world environments. And this makes this work practical and applicable in the real time systems. And we are also working on the EV security. That is our future work. So let me go through the. Oh, okay. All right. Let me go through the introduction part. So this is the order of presentation, and then this is the introduction part. So the modern applications such as the healthcare systems, like or in the banking platforms, or even the e-commerce applications, they rely on the continuous interactions with the backend databases, and these systems processes the sensitive data. So one of the, while the system processes the sensitive data like the personal information or the login credentials and even the financial records. So one of the major threats is the SQL injection, where the attackers insert the malicious SQL queries into the input fields, and this allows the unauthorized access to the databases or modify the data. They can steal the data. Anything can happen to the database. So with respect to the traditional systems, like the web application firewalls, they use a rule based detection techniques. That is a old technique, but the attackers now use obfuscation, okay, techniques such as the encoding or the query manipulation, and also they try to bypass the rules, and this should not happen. Therefore there is a need for the intelligent systems that can learn the patterns dynamically, okay, and more accurately, so that it has to be quickly mitigated, and then it has to continue the work. It should not stop after the mitigation. It should not stop. It has to continue the work. So we use our machine learning algorithms to analyze the query structure and also detect they improve the accuracy, right? So this is about the introduction. Let us go. Let me, this is the problem statement. So the core problem addressed in this work is the vulnerability of the database driven systems to the SQL attacks. And these systems generate SQL dynamic queries using the user input. Okay, and if the user input validation is weak, the attackers can inject the malicious code. For example, say a tautology attack like the or one equal to always evaluates to true, okay, or 1 equals to 1 is always equal to true, and that allows attackers to bypass the authentication. So the union based extraction, I have also mentioned about the union based attacks are used to extract the hidden data from the databases, right? So and also the comment truncation, okay, that are comment based injections are also used like a dash to ignore the parts of the queries. Additionally, some of the attackers use the encoding techniques to hide the malicious patterns. So I have already discussed about the traditional techniques. So therefore we need a system that is both accurate and it should be adaptive. All right. So I have discussed all of these, the real world impacts, how it is going to impact if it is not resolved immediately. Finally, we'll go to the solution here. To address these challenges, we propose a AI-driven SQL ingestion detection system that basically addresses, analyzes, addresses, and mitigates. Okay, first it analyzes the SQL queries at the character level. Okay, instead of instead of relying on the keywords, the systems looks for a pattern. Okay, if the same pattern is detected, then then it is like there is an anomaly in the system, like the patterns formed by the characters such as the operators or the symbols or delimiters. Okay, and we use a multiple machine learning models that includes the logistic regression or the support and the logistic regression, the support vector machine, that is SVM, the random forest, and one dimensional convolution networks. Okay, or 1D CNN. So and then logistic so these machine learning algorithms are used. And then the logistic regression, we all know that it is a linear model, okay, that is used for the classification, while the STM, it is for the optimal boundaries between the classes. And then we have a random forest, that is that ensemble the models, that combines multiple decision trees, okay, and also improves the accuracy. And many other models we have used in this process. Okay, the system is deployed using the REST API, and it means that it can receive the queries and return the predictions in real time. So the REST API is used here. All right. Then comes the objectives. The main objective here is of this research is to develop a machine learning based system that automatically detects the SQL injections attacks. So we aim to classify the queries into um, malignant and then a malicious category with higher accuracy. So another objective here is to compare the different models. Not only one, not only two or three models. We have, as I discussed, we are using five models. Okay, so these will be compared, and we also focus on the feature engineering, which means that the feature extraction. So it should be a useful information with respect to the SQL queries. So in this work, we use a character level analysis because the SQL injection attacks often depends on the structure rather than the meaning. Correct. So another important the goal is to reduce the false positive to ensure that the legitimate queries are not blocked. Okay, it has to be processed quickly. So they, based on the pattern, it has to be analyzed and it has to be detected, and it should be marked malignant. Okay. Finally, we deploy the system in the REST API for the real-time detection and making it more practical for the integration into the modern applications. So these are the related works. So the traditional SQL detection systems, I have listed few papers on this, and even the classical ML models, okay, to improve the detection accuracy, that I have also listed, and deep learning techniques and ensembling the learning offers with a high accuracy. All these related papers I have discussed. Okay, let's move to the next slide. The proposed work, okay, this is very important. In this work, as I discussed, we design a complete machine learning pipeline for the SQL injection detection. The pipeline includes the data collection, the processing, the feature extraction, and then the model training, right? And then the evaluation and then extraction. These are the pipeline structures. And we use a data set which is of 30,919 SQL queries. So that contains both normal and malicious samples. So during the pre-processing, what happened? We remove the duplicate queries and handle the missing values and normalize the text. And in the feature extraction, this is performed using the TF-IDF, which stand for the term frequency inverse document frequency. That is term frequency inverse document frequency. Yes, this technique is used, and this method basically assigns the weights to features based on how important they are, and it captures the patterns such as the such as the repeated operators or the symbols. Okay, because this is a character based, so it tries to catch all these the operators, the delimiters or the symbols in the queries. For deep learning, we use a tokenization and then the embedding techniques to represent the queries as sequence. So, and then later it has to be trained. The model has to be trained and evaluated, and the best model is selected for the deployment purpose. Okay, this is the proposed work, and this is the architecture. The system architecture, they basically consists of the multiple stages. The first is the SQL query. It is it is received as an input, and this query is pre-processed to remove the noise and then standardize its format. Okay, and then next is a feature extraction is performed, and then in a TF IDF term, the frequency means how often a pattern appears in the query. Okay, while the inverse document frequency, it reduces the importance of the common patterns. So the formula, everything I have provided in the next slide. So the TF IDF is equal to TF into log n by df. Okay, where n is the total number of documents and df is the document frequency. All right. So finally here the model predicts whether the query is malignant or malicious, and the result is returned through the REST API in the JSON format, and this architecture ensures that the real-time detection and scalability. Right?
Excuse me, ma'am, you have 1 more minute to conclude your presentation.
Okay. Um, I have discussed about the methodology and then the results, the experiment results. Or as I discussed, all these models were trained and tested on the pre-processing data sets, and the queries within the 80 to 20 training and testing split, and the classical models used TF and IDF features, while the CNN used the tokenized sequences, and mm, the results I have provided in the in all these slides. Okay, and then this table consists of the models that I have used, and the accuracy and the precision and the recall, all these parameters I have provided here, and the random forest achieved the highest accuracy of 99.68. Okay, so therefore it is therefore selected as the final model for the deployment. And then here is the conclusion and future work. In this research basically demonstrate that the machine learning can significantly improve the SQL injection detection. And by using the character level features and extraction and supervised models, we can accurately classify the SQL queries. Okay. So in future work, we plan to improve by adapting the system by integrating with the online learning techniques, and then this will allow the model to update itself when a new patterns emerge, and also we aim to explore more advanced models such as the transformer based architectures, or the even we plan to use the agentic AI and make it more interactive, include the chatbot. Okay, these features can be added along with the informative AI or the agentic AI. Okay. Uh, Thank you for your time and attention. And this work demonstrates how AI and machine learning models can be applied to improve the cybersecurity in the modern systems. Okay. Um, Thank you all.
Thank you, ma'am, for your presentation. Sir, do you have
And
any questions?
one more
Yes,
thing. And
yes,
this
one
work is
question.
Yes,
supported.
sir.
Fine, ma'am. Go ahead. Go ahead.
Sorry, this work is supported by the Board of Regents, Louisiana Board of Regents, and then the National Science Foundations. Um, And then these
Fine,
are the
fine,
references.
fine.
Yes, sir.
Congratulations, madam, for getting paper accepted in the journal. Just my one question and some future work related to this particular task is, now you compared the SQL injection. Maybe in future you can compare the other attack, something like no SQL injection or LDAP injection, and then probably even you need to take care of the confusion matrix also. Right now you have put that one of the machine learning algorithm is better for something like random forest, right? So
Yes, sir.
maybe for other attacks, random forest might not provide the accurate result compared to SQL injection. So you can do the related work as part as a future. Thank you.
Yes, sir. And I would like to mention here that this is my student work, and he could not be up until now, so I
That's
presented
fine,
on
fine,
behalf
ma'am.
of
No issue,
him.
ma'am. No
Yes.
issue.
This is very basic, but still, they have taken. I mean, still he's an undergraduate student. He has taken more effort to like do this project.
Fine,
Thank you all. Thank you
fine.
again.
Thank you so much, ma'am, for your presentation. Now I'd like to call upon the next presenter, Amina Abdo ma'am, to present her paper titled An Ensemble Learning Approach to Cardiac Catheterization. Ma'am, you may start presenting now. Okay, I assume ma'am is not present as of now, so we can move to our next presenter. Sai Jagnasini Rana ma'am to present her paper titled An EOQ Replenishment Policy with Varying Deterioration, Stock Sensitive Demand and Money Inflation. Ma'am, you may start presenting now.
Gayatri ma'am, are you there?
I assume our second presenter is also not present as of now, so
Ma'am,
we can move on
just a second.
to.
What you can do, you can tell them to write down the thumbs up on the WhatsApp, ma'am, so that we can, those who are present, we can start that time.
Okay, sir. We can move on to our next presenter, R. Harish Khanna, sir, to present his paper titled Analysis of Financial Market Dynamics Using Neurocomputing for COVID-19 Regime Transitions. Sir, you may start presenting now.
Yeah, sure. Give me a second. I'm audible.
Yes, sir, you're audible. You can start presenting.
Yeah. Good morning, everyone. I'm Arishkana Ramamurthy from SSN College of Engineering, Chennai. Today, I will be presenting my paper, Analysis of Financial Market Dynamics using Neurocomputing for COVID-19 Regime Transition. The co-authors are Dr. Ahana Priyanka and Dr. Snega Nandini. Let me straight into it. Okay. So, what is the paper actually trying to do? We wanted to design a neuro-inspired framework to understand how financial market behaved during COVID-19. Not just what happened to price, but why the market made that decision it did. Next, an introduction. To understand why this matters, let me start with a simple observation. In traditional finance, assumes a market are rational. But if that were true, the prices would never crash 40% in 3 weeks. Let me see it happen. In reality, market behave like human, not machines. They panic, they overreact, and COVID-19 was the ultimate stress test. Prolonged, repeated shocks, unlike anything market has seen in modern history. Let neurofinance concepts have never been tested on large scale real world data. This is the gap we are filling. Need of the work. So, what specific gap does this paper fills? 4 gaps. 1. Existing neurofinance model could not scale to real market data. Then 2. There is no standard way to measure market uncertainty as a single trackable number. 3. The Indian market Nifty Bank is almost absent from behavioral finance research. And 4. The risk management model failed during COVID-19. We need a framework that warm partitioner become the crash, not just been afterwards. That's the objective of the work. So we set 5 clear objectives. Map market behavior to 5 prime region decision systems. Build a unified neuro decision score and test whether COVID-19 caused a measurable shift or not. Measure how long a market stated lost and how often they switched. Then classify daily activation states per system. And then answer the big question, did market go back to the normal state after COVID, or did they form a completely new equilibrium? These are the objectives of the book. The flow of the diagram. Let me walk you through how we build this. Figure 1 shows the complete pipeline. 4 stages. First stage, we used 1,516 trading days of Nifty Bank Index and 773 days for pre-COVID and 743 days for post-COVID, a clean symmetric comparisons. Stage 2, raw data was converted into 25 market features covering price, momentum, volatility, and volume. And stage 3, we trained 5 XGBoost classifiers, 1 per prime system. Each one answers a simple daily question. Is the system active today or not? Stage 4, all 5 output combine in a neuro decision score. 1 number per day capturing the market overall cognitive state. Then we validate it using a 6 method, including a run length analysis and channel entropy and 4 statistical significant tests. Up next, the framework decision design. Now, table 1 shows the 5 system and the prime region mapping. Let me explain each one. When traders sees an opportunity, the VMPFC, our value system, captures the greed and opportunity seeking via RSI and momentum. When volatility spikes, the AMELDA and our risk system takes over. Pure fear and threat detection. When everyone starts moving together, earning, and that's the DMPFC or sentiment system. When some things feels completely abnormal, a gap, a volume spike, the insula fires, guilt feeling, anomaly detection. And finally, DLPFC, our control system, coordinates and filters all other system together. This 5 give us a complete cognitive footprint of the market on any given day. Next, the results. So, what did the data actually shows? Look at figure 2. These 2 charts tell those old story. Top chart, the pre-COVID chart. Notice how the 5 system move independently. They take turns. This is the healthy market. Different cognitive channel processing information separately. Now, look at the post-COVID chart. All 5 systems are evaluated simultaneously for sustained periods. They stopped operating independently. The risk system showed the largest single increase. The AMELDA never fully turned off. The market lost its ability to think through separate channel. That's our first major finding. Up next, the NDS distribution shift result. Let me put a number on this, figure 3 and table 2. The NDS measures the balance between value seeking and risk dominant behavior. 0 means balanced, negative means fear is winning. Pre-COVID mean NDS was 0, and post-COVID mean is dropped to minus 2.01. Is this a noise? No. We ran a four independent tests, KS test and a permutation test and a covariance test and unity due, and all four turned P less than 0.01, and covariance D test was minus 0.639, shows medium effort size. Our ML based NDS improves the effect size further compared to a simple rule based version. This is not noise. This is structural permanent shift in the market makes these decisions. Up next, the market rigidity and a paradox result. And here is where it gets really interesting. Figure 4 shows what we call the market paradox. After COVID-19, the market state lost 24% longer. System switched less. On paper, this looks like stability. But simultaneously, the NDS is deeply negative, which is in risk dominant state. The volatility went from 2.01 to 4.85, which is increased. The higher stability and high risk at the same time. This should not coexist at all. So we call this as a vigilant God state. The market is
Excuse
not
me, sir. You have 1 more minute to conclude your presentation.
Yeah, sure. The market is not calm. It's permanently alert, like a soldier who never gets stand down. The market did not recover. They formed a completely new equilibrium. Any risk model trained on pre-COVID data is symmetrically underestimate tail risk today. Next conclusion. To wrap up, 3 things in this paper establishes. Conclusion 1, structural change confirmed. NDS shift from 0 to minus 2.01. All 4 tests agrees. Permanent regime change. Conclusion 2, the framework works perfectly with the accuracy of 96 to 98% across all 5 classifiers. Neuroscience at scale on real data, market data. Conclusion 3, the implication are real. Post-COVID markets are more persistent and more dominant. Future work will extend to Nifty 50 and global indices and live real-time NDS dashboards. Thank you. Thank you so much. I'm very happy to take questions.
All right. So thank you for sharing the ideas. I hope you all learned the handsome money by applying the neuroscience market.
Yeah.
Fine. Just one question. Can you compare the same scenario of COVID with the today's current scenario of war? And will your neuroscience work in that case?
Sorry, sir, I can't hear you.
Can you compare the COVID-19 situation with today's current scenario of a war? Because even a war has boiled down the market scenario even further.
Sir, not at
that is what I'm saying.
Continue
the
in the
second
future.
thing is you need to consider the parameter, that is the volatility.
Yeah.
Once the volatility index cool down, we are getting the idea that at least now the market is getting stable, whether it's a COVID or whether it's a war. So these are the few things even you need to consider also in a detailed part. Because right now we don't have COVID scenario that has gone back since 2020. So we need to work on probably a future part and the future area. So it's
Yes.
fine. Thank you.
Yeah. Thank you, sir. Thank you so much.
Thank you, sir, for your presentation. Now I'd like to call upon our next presenter, I. Mint, ma'am. to present her paper titled Comparative Analysis of Machine Learning and Transformer-Based Models for New Topic Classification in Low Resource Myanmar. Ma'am, you can start your presentation.
Yes, sir. Yes. Yes. And can you hear my voice?
Yes, ma'am, you're visible. You may start.
Yes. Okay. Good afternoon, everyone. My name is Isanamia from University of Computer Studies, Yangon, Myanmar. Today, I will present my research title is Comparative Analysis of Machine Learning and Transformer-Based Model for News Topic Classifications in New Low Resource Myanmar. This research focuses on applying natural language processing techniques to automatically classify Myanmar news articles into different topics and comparing the performance of traditional machine learning, deep learning, and transformer-based. This is the content of my presentation. In introduction, topic detection is an important task in natural language processing. It automatically categorizes large volume of text to predefine topics. This technology is widely used in search engine, news portals, and digital libraries. However, most NLP research focuses on high-resource language such as English or Chinese. In contrast, Myanmar language NLP research is still limited, mainly due to the language complexity and lack of resources. Therefore, developing an effective NLP system for Myanmar language is an important research area. And there's a motivation. The motivation is the research comes from the rapid growth of the online news contents. Myanmar news website publish thousands of the articles every day. Currently, many of these articles may categorize manually, which is time-consuming and inefficient. Automatic classification is a significantly improved information retrieval and content organization. This is a research challenges. However, applying NLP to manage Myanmar language present several languages. First, Myanmar language does not have clear word boundaries, unlike English. This makes word segmentations and organization difficult. Second, there are many limited annotated diseases available for training machine learning models that Myanmar NLP still less of standardized tools and resources compel the Myanmar language. Because of these challenges, developing effective models of Myanmar text classifications is still open the research problem. In this research objectives, the main objectives of this research are first, what level segmentation techniques in Myanmar text. Second, compare the different classifications model, including the traditional machine learning model, deep learning model, and transformer-based model. That to evaluate their performance using standardized evaluation metrics, finally identifying the best performing model for Myanmar news topic classification. In the datasets for this study, we collect Myanmar news articles from online news portals. These datasets contain approximately 60,000 sentences. These articles are categorized in 12 news topics, including like that: agriculture, art, crime, disaster, economy, education, foreign affairs, and so on. In the data processing, before training the model, several processing steps were performed from noise removal and stop word removal, and the normalization was applied to standardized Myanmar text encoding. And fourth, the word segmentation is performed because the Myanmar language does not contain explicit and word boundaries. In the system architecture, overall, the systems architecture follow the several steps. One, the data collection. First, the data collection. Second, data preprocessing and word segmentations. And then fourth, organizations and the model training. And then the next. Finally, we train the model performs topic prediction for news articles. In this is the architecture of iSystems. In this research, we compiled three types of models: traditional learning model, including logistic regression, neighbors, and deep learning model, LSTM, long short-term memory, and then the transformer-based model, including multilingual part and MPART. This is the experimental setup in this. We conduct using the Intel i4 i5 processor, NVIDIA 3050 GPU. The evaluation used several frameworks, including Python and Scikit-learn. And the data splits into 80% training and 10% validation data and 10% testing data. Evaluation metrics. To evaluate the model performance, we use several metrics. The main metric is accuracy, which measures the percentage of correctly classified samples. We also an advanced score, which balance the precision and record. Additionally, loss and rate norm. We monitor during the transformer model training. The metrics have both model performance and training scalability. This is the result. The results show clear difference between models. The accuracy results are logistic 0.73, NAPIS and 0.63, LSTM is 0.85, BART and 0.787, and MBART is 0.95. The model. This feature is the model performance of Myanmar news topic detection or log level segmentation. In the key findings from this experience, several key findings emerge. First, work level segmentation significantly improves the classification performance. Second, deep learning model perform better than the traditional machine learning model. That transformer-based model achieve the best results, especially MBART. These highlights are effective of transformer architecture for low resource languages. In conclusion, this research compared multiple models of Myanmar news topic classification. The research showed that MBART achieved the highest performance with advanced score of approximately 0.95. The study also confirmed that transformer-based models are highly effective for low-resource languages. Additionally, proper word segmentation plays an important role in improving model performance. In future work, several improvements can be made. First, expanding the dataset to include more news articles and categories. Second, experimenting with more advanced multilingual models such as XML, and MD5 that developing real-world applications such as automated Myanmar news classification system. These improves can further enhance Myanmar NLP research. Thank you very much for your attention. I appreciate the opportunity to present my research. I would like to happy to answer any questions. Thank you.
Fine. Thank you, ma'am, for your presentation. Is my voice audible?
Yes.
Maybe in your future work, you can consider something like a fake news part also.
Yes, sir. Sorry, sir.
Fake news related to information.
Fake news.
Yes, as well as you can try to focus on the confusion matrix, because in this particular kind of paper, the false positive rate plays a very important role in justifying your result.
Yes, sir.
I hope you get my point.
Yes, sir.
Fine, thank you.
Yes, thank you, sir.
Thank you so much, ma'am, for your presentation. Now I'd like to call upon our next presenter. Min Wai Yang Wu, sir, to present his paper titled Integrating Storytelling and Game-Based Learning in Primary English Education, a teacher-based needs analysis. Sir, you may start presenting now.
Yes. Let me share my screen. Hello, can you hear me?
Yes, you're audible. You can start.
Yes. Okay. Good afternoon, everyone. My name is Min Wei Yang Wu. Now I like to present. I'm from the researcher from the King Mongkut Institute of Technology in Nagavan here in Thailand. Today, I'd like to share my work on the integrating storytelling and game-based learning in primary English education, especially for a teacher-based need analysis. So let me start with the problem. In Myanmar, despite the English language learning at the primary level faces serious challenges. Students who don't use the English outside the classroom struggle to stay motivated. Like the traditional teachings, uses heavily on textbooks and memorizations, often fails to hold their attention, especially from the young learners aged from 5 to 12 have a short attention spell. At the same time, today's students are growing up as digital learners. They used to interactive multimedia experiences. So the gap between how they learn best and how they are being taught is widening. So this is exactly where the digital storytelling combined with the game-based learning offers a solution, providing engaging and language exposure that meets the student where they are. So to investigate this, I conducted a qualitative need analysis. My research question is, what are the sixth grade teachers' needs for the game-based learning using interactive digital storytelling? So I experimented with the semi-structured interviews, which is an approach that allows teachers to speak freely about their real classroom experiences. So the interview was analyzed using the content analysis and thematic coding. So I interviewed the 6 English teachers selected using the purposive sampling. All of them were currently teaching at the primary level and had the experience with the 6th grade students. Importantly, they were all familiar with the digital learning materials. The group were evenly split by gender and all between 20 to 29 years old and come from the both private and international school settings. So the interview was revealed 3 main things. First is teachers face real challenges. Like students lose focus in the traditional lessons and adding the game-based activities require extra preparations and classroom management. One teacher said, I quote, more time and more class control would be required when using games in the lessons. This reflects the genuine tension between the engagement and control. Second, teacher were largely positive about digital storytelling. They saw videos and visuals and sound effect are powerful tool. As one of the teacher perks, like student can see and hear at the same time is very effective. And the multimodal nature of the digital story support both comprehension and memory. For the third, teachers express a clear need for interactive apps, one with the embedded task, immediate feedback, and a simple web-based interface that doesn't require installation or technical setup. So based on these set findings, I developed a prototype of applications called Story Bubbles. In the Story Bubbles, it translates every teacher needs into a concrete design features. So in the feature A is the student selection screen where the student chooses the avatar before the story begins. The simple step gives them the ownership and boosts the initial motivation. The feature B is a narrative story scenes, colorful illustration with the short and age-appropriate text. The visual design intentionally minimal to reduce the cognitive overload. So in the feature C, where the game-based learning happens, embedded interactive text, including multiple choice questions, rhyme recognitions, and a word puzzle appear directly within the story flow, not as separate exercises. So in the feature D is a reward screen after the completing a task. Students receive badges and a completion score. This immediate positive reinforcement sustains motivations and signal this process. So this slide shows a direct link between what teacher asks for and what we build. So every row in this table represents a teacher need. On the left, it's a corresponding design feature. In the center with the underlying of the game-based learning principle, and on the right. For examples, like if the teacher wanted the immediate feedback, so we build a reward screen with the badges. Teacher wanted the learner autonomy, so we added the character selections. So this table is the evidence that Story Bubble is teacher-informed and user-centered design, not just a technological experiment. So to conclude this study confirmed 3 things. First, there is a clear gap, which is traditional English instructions not meeting the needs of generation learners in Myanmar. Second, is the teachers agree on the solutions. They want the interactive digital storytelling with embedded test, feedback, and rewards. And third is the Story Bubble demonstrate that teacher-informed, user-centered, and design can bridge the theory. And for the future research, my priority is to conduct a classroom-based intervention study, testing the story bubbles with the real students and measures impact on the vocabulary acquisition and student engagement. I also plan to expand more grade levels, eventually other languages. So this research is supported by the Kim Il-sung Institute of Technology. And thank you for your attention. I'm happy to take any questions.
Thank you. Is my voice audible?
Sorry.
Is my voice audible?
Yes, audible.
Fine, fine. So very interesting topic. Actually, what you can do as a future part, you need to consider different interdisciplinary subjects. So that might change your idea. Right now, you have taken a small database of 6 teachers. That also you need to increase. And similarly, you can widen your scope. That is a very interesting topic.
Yes.
Congratulations.
Thank you.
Thank you so much, sir, for your presentation. Now I'd like to call upon our next presenter, Maharajpet Sheila ma'am, to present her paper titled Predictive Modeling Approaches for Detection of Skin Diseases, Future Research Directives. Ma'am, you may start your presentation.
Able to hear her voice. Started. Hello, Gladys ma'am.
Excuse me, ma'am, are you trying to speak?
Yes, I'm not able to hear her voice.
Yes, sir, she's not audible. No, ma'am, you're not audible still. Can you hear me now? Yes, ma'am, you're audible. You can start. Thank you. Sorry for the disturbance. Okay. A very good morning to one and all present here. I'm Professor Sheila S. Maharajpet, currently working as an assistant professor in the Department of Master of Computer Applications at Cherry Institute of Technology. So today I'll be presenting my work titled A Comparative Statistical Model Approach for Skin Disease Detection. So this work mainly focuses on using machine learning techniques to improve the accuracy and efficiency of skin diagnosis. So coming to the introduction part, as we all know that skin disease are among the most common health issues that are affecting the people that is worldwide, and early diagnosis is very important for effective treatment. So, however, what traditional diagnosis we often use that is often subjective and depends heavily on the experience of dermatologists. So, which can sometimes lead to inconsistency. So, with the advancements of technologies like machine learning, which provides an opportunity to automate this process, making it faster and more reliable. So in this study, we use KNN, that is K nearest neighbors, then SVM, support vector machine, and we are using random forest models to perform a comparative analysis of skin disease detections. So as why this, despite the progress in this machine learning domain, there are several challenges which still exist. The that is the early detection is often delayed, and especially in areas where with limited medical facilities, and manual diagnosis is very it is subjective, and based on their experience they are going to diagnose it. There are so many challenges to overcome. From that we propose this classical machine learning approach. So this is my literature survey. So in this literature, there are various approaches have been proposed for skin disease detection. Some studies use SVM, some used ANN, some used LDA, achieving moderate accuracy but relying heavily on the feature selection. So other works compared with the RF, that is random forest. You can see the references here. I have mentioned what methods they have used, how much accuracy they have achieved, and there were some limitations also. So this is about my literature survey. Coming to the methodology, this is my methodology. This methodology consists of several steps, as you can see in the diagram. First, the input of the skin images are pre-processed, that we input, that will be pre-processed to improve the quality and remove the noises, some duplicates or some the blurry images are there, that we will remove here. In the next step, we extract the important features, as you can see in the diagram, using some techniques like color moments. Then we have GLCM and LBP, which help in capturing color distribution and texture uh, formatting. So these features we then used input machine learning models such as KNN. As you can see in the model, whatever the data's website, that will be passed through the models like KNN, random forest model, SBM model. And then finally, these models will be evaluated using whatever the inputs will give, that will be evaluated using the performance metrics such as accuracy and precision, recall, and F1 score, and which is then harmonic mean of the precision and the recall, and then we'll select the best model based on the accuracy what we are getting using all these models. Coming to the next one, that is the results. As you can see in the diagram, the results show a clear comparison between the SVM, RF, random forest, and the KNN. As you can see in the table, the random forest achieved the highest accuracy, that is 73.5%, and also showed the strong precision performance, whereas the KNN performed efficiently with a lower execution time and the make it suitable for faster predictions. Whereas SVM, that is support vector machine, showed better recall, meaning it is very effective in identifying the positive cases. So here, the these results indicate that each model has its own strengths, and the choice of the model depends on the specific approaches or application requirements. So coming to the conclusion and the future extraction. So to conclude that, as we have seen in the results, which shows that the random forest delivered uh, which provided the best overall performance in terms of the accuracy. However, the selection models, it totally depends on the what is the requirement. Based on that requirement, you can select the model. And among all the models, random forest RF provided the best overall performance. And then however, the selection of the models, it depends on the factors such as the data size and computational resources and the importance of the precision versus the recall. So in future, we are planning to extend this approach by using the larger data sets, the improving the pre-processing techniques, and integrating deep learning models to further um, enhance performance. Thank you. Any queries?
Just a small suggestion or a correction you can take care in future. Whenever
Yes,
you
sir.
are going for a literature survey, try to
Okay.
add the year also so that we can get an idea whether it's the latest paper or not.
Sure, sir. Sure. Definitely.
Second, there are a lot of works which have been already published in this particular area. So
Yes, sir.
probably you can go for a future part as something like a generative AI technique,
Yeah, sure, sir. Sure, sure.
like
That is what.
line shape and some other parts.
Sure, sir. Sure, sure. I'll
Another
definitely.
thing nowadays, instead of focusing on the data set, since it's a part related to a medical field, right now probably we need to go for a clinical data rather than data.
Yes, sir.
So it
Yes,
might get deep for your result also in terms of comparing the machine learning. So
exactly,
that
sir.
is the few suggestions from mine.
Sure, sir. Definitely, I'll take these suggestions. Thank you so much, sir. Thank you so much, ma'am, for your presentation. Now, I would like to call upon our next presenter, Malika Suyunova Odilkizi ma'am, to present her paper titled Sentiment Analysis of Uzbek Social Media Posts, Methods and Research. Ma'am, you may start presenting now.
Good morning. Can you hear me?
Yes, ma'am, you're audible.
Just a minute. Can you see my presentation? Can
Yes,
you
ma'am,
hear
it's
me?
visible. You may start.
My name is Malika Syunova, and I am from Alisher Navoy Tashkent State University of Uzbek Language and Literature. Today, I will present our research on sentiment analysis of Uzbek social media texts. The main objective of this study is to develop effective approaches for sentiment classification in Uzbek and to compare different models. So let me begin with the presentation. Corpus and task. In this slide, we present the dataset used in our study. We collected 100,000 Uzbek social media posts from Telegram, Instagram, Twitter, and Facebook. The data were manually annotated into three classes: positive, neutral, and negative. The corpus mainly uses Latin script and includes code switching, spelling errors, emojis, and abbreviations. The dataset is well balanced, which is important for training reliable models. Overall process. This slide shows the main stages of sentiment analysis. First, we collect user-generated posts. Then we aggregate and process the data. After that, we convert text into numerical form using embeddings. Finally, classification is performed assigning each post to positive, negative, or neutral classes. Pre-processing pipeline. Pre-processing is a crucial step. We start with cleaning by removing noise like links and unnecessary symbols. Then we apply tokenization and remove stop words. Next, normalization corrects spelling and huntless code switching. Finally, stemming and lemmatization help extract meaningful word forms. Feature extraction. In this stage, we extract useful features from text. We use TF-IDF to measure word importance, and grams help capture word sequence. We also use lexicon-based features and handle negation patterns. These features are then used for classification. Models evaluated. We evaluated several models. Naive Bayes is fast but less accurate. SVM performs strongly among classical models. BL-SITEM captures context and gives good results. BERT and RoBERT achieved the best performance around 92%. CRF was also used for token level tasks. Proposed model architecture. This slide shows the full system. We start with preprocessing, then apply fast text embeddings. Next, deep learning layers extract features. After that, fuzzy logic is applied using membership functions and rules. Finally, a decision tree produces the sentiment classification. Results. This slide compares model accuracy. Naive Bayes achieved 78%, SVM 88%, LSTM 90%, and raw BERT reached 92%. Transformer models performed the best overall. Class-wise performance. Here we analyze the performance by class. Neutral class is more difficult, with about 85 accuracy. Some neutral texts are misclassified due to mixed sentiments. Positive and negative classes show higher accuracy, around 92%. Cross-validation results are stable, confirming model reliability. Efficiency and deployment. This slide focuses on efficiency. Naive Bayes and SVM are very fast. LSTM requires more time and BERT is the slowest. We recommend a hybrid approach. Use SVM for fast filtering and BERT for complex cases. Language-specific insights. This slide highlights Uzbek language challenges. Agglutinative structure makes processing harder. Handling emojis and abbreviations improves results. Using Uzbek-specific pre-trained models like UzBERT significantly boosts performance. Conclusion. In conclusion, transformer models achieved the best results for Uzbek sentiment analysis. Language-specific preprocessing played a key role in improving accuracy. A hybrid system is recommended for practical use. In future work, this research can be extended to aspect-based sentiment analysis and real-time applications. In this study, sentiment analysis of Uzbek language texts was performed and the performance of different models was analyzed to determine which ones provide the best results. Thank you for your attention.
All right, fine. Thank you, madam. Maybe as a future part, as rightly mentioned, you can focus on the real-time data. Something like a Facebook or a Twitter. I hope she's getting my point. Is my voice audible?
I have some internet problems and I cannot hear your
Fine,
question.
no issue, no issue. Thank you. It's fine. Gladly, ma'am, we can shift to the next presentation.
Thank you. Thank
Okay.
you.
Thank you, ma'am, for your
presentation.
Now I would like to call upon our next presenter, Sriram VA sir, to present his paper titled Smart Campus Surveillance and Guidance System. Sir, you may start presenting now.
Hello, ma'am, am I audible? Hello? Hello, ma'am, am I audible?
Yes, sir, you're audible. You can share your screen.
Good afternoon, respected chairman, judges, and fellow participants. Hello, am I audible? Hello?
Yes, you can go ahead, no issue.
Okay. I'm V.S. Sriram, and along with my team member, I'm presenting our project title, Smart Campus Surveillance and Guidance System. Under the guidance of our mentor, Dr. M. Bhav, from Rajalakshmi Engineering College, India, Chennai, India. Our project basically aims to improve the campus safety navigation using artificial intelligence and GPS technology and cloud-based monitoring system. A simple introduction to our project. A smart campus surveillance system is designed to improve the campus safety and navigation features. Since many newcomers to the campus face difficulty to navigate and identify the campus locations in our campus. Students and visitors often face difficulty locating classrooms, while security teams struggle to monitor unauthorized movement in the campus. A conventional CCTV system provides only a video recording without intelligent assistance or real-time alerts. To address these challenges, Smart Campus Surveillance Guidance System has been proposed. A typical challenges faced or difficulties in campus navigation. A passive surveillance system. A passive surveillance system also can be considered as a traditional surveillance system without any ethic or advanced surveillance system. A delayed response to incidents and lack of access controls and disconnected system. And helps and high dependence on manual monitoring. These are the challenges we have been overcome. The proposed methodology for these problems are cloud-centric architecture. A centralized system processes data from camera and GPS devices for real time. We have integrated cloud, Google Cloud API in order to view a real-time campus map, which a user can interact with the map to align his movement to the respective designated location through this method. Data acquisition. CCTV camera captures videos and GPS trackers to use location across the campus. Intelligent processing. OpenCV and AI models analyze video and face detection and active monitoring. Face recognition model captures face with database to verify authorized users. Geofencing mechanism gives an understanding about the campus boundaries to the new users. This is the architecture. The way our system works are this is basically a split system. This is basically a split solution that we have proposed. A student name registered along with their block, classroom, and timetable, along with their in-charge email ID. A CCTV camera captures a real-time video across the campus. Face recognition is used to identify the student from the various locations. A system tracks the student's current location and sends mail if he trespasses are marked in any other classes. It compares the location with the student's scheduled classrooms and timetable. Student outside the assigned classroom blocks marked unauthorized movement or trespassing. System sends an automatic mail alert to the concerned in charge through SMTP, a simple mail transfer protocol. Alert includes students' detail and location mismatching. All surveillance data is stored in the cloud. Data is used to monitor future analysis. These data are used for monitoring and for future analysis. And this is our another split solution. Along with this another split solution, we have another a guidance system. Another system, guidance system, what a user can open the guidance system and log in, and he can simply use it to access the to analyze the destination from where to he can go. This is the workflow diagram. Tech stack, HTML, CSS, JavaScript are used for front end, backend cloud, Python, cloud, Google Cloud Platform, and cloud database. Email notification, SMTP, simple mail transfer protocol used. Guidance system. These are the API we have integrated with this Google Map API, geolocation API, and new place API, etc. Surveillance system, computer vision, CV2, face detection and recognition, data handling, image processing, file management, and folder handling, time tracking. And tools and libraries, OpenCV, MediaPipe, NumPy, and Pandas. Real-world deployment can be used in colleges and university for safety navigation.
Rather than just a second, rather than focusing on theoretical part, you can directly shift to the project one. Conclusion.
So no, I couldn't get it, sir.
So this is all theoretical only.
What, sir? Hello?
Is there anything you want to show? Otherwise, this is all theoretical.
Yes, sir. Yes, sir. Yes, sir.
So directly shift to that part. Yes, output comes.
Okay. This is our deployed project for, this is how it works. A student can, we have also given a 3D, like a person comes to the campus, he doesn't know a location where to go or how to go to a certain location. He can use a given QR will be given at every point of the campus, and he can scan and he will get into the this site, and he can navigate along with the this app. And this is our face recognition system works. Building is selected, like we can give any kind of name for buildings or campus, and name, identity, ID name are given. Image is taken, processed, and tracked along with the sender mails and receiver mails. Receiver mail will be a monitor or a specific managed monitor for a specific student. He can call for. Conclusion: improves campus safety using face recognition and timetable monitoring. Provides real-time navigation to locate campus facilities easily. Uses automated alerts for quick response. Cloud monitoring makes the system effective and reliable. The system scalable for future expansion. Thank you.
I think it's probably a student project, so I won't be able to provide much suggestion to it. Otherwise, it's fine.
Okay, sir. Thanks. Thanks. Any questions, sir?
I guess there are no questions from Sir's side. So thank you so much, sir, for your presentation.
Thank you.
I would now like to call upon our next presenter, Mugdha Kulkarni ma'am, to present her paper titled Unmasking Dark Patterns, a data-driven framework for detection and user awareness. Ma'am, you can start presenting now.
Hello, thank you, Gayatri. Dia?
Yes.
Just a second, screen is coming up.
Yeah, they are sharing the screen.
Hello, good morning, everyone. Just a heads up, a couple of us are presenting today. That is me, Diya Oswal, and Mugdha Kulkarni. So, starting, uh, today we will be presenting our work on unmasking dark patterns, where we study how seemingly small design choices in interface can significantly influence user decisions. So, before getting into the technical side of it, I think all of us have experienced something similar, that when we go shopping online, we see a product for rupees 1000. But by the time we reach the checkout, it generally adds on some taxes and becomes somewhere around 1200. So that is an increase of about 20% because of hidden charges. Or we often see messages like only 3 items left, limited time offer. And we often feel like, oh, this is so urgent, we need to act immediately or we might miss it. Now, the interesting part is most of us don't even realize that we are being influenced. These are called dark patterns, which are design techniques that deliberately manipulate and nudge users into decisions they didn't fully intend, but they intend to benefit the platform over the user. So our focus is on detection of these dark patterns. Next slide, please. Yes. So the problem with these patterns is that they are not rare. They're actually very widespread among all digital platforms. But at the same time, they're very hard to detect because they look like normal designs and we are so used to it that we don't even realize that we're being influenced by them. This is not just a usability issue, it has real world consequences. Large companies have actually faced legal action and heavy penalties for using deceptive design practices. For example, in 2023, the FTC filed a case against Amazon related to its Prime subscription flow, where users were allegedly manipulated into signing up and faced difficulty while canceling. So clearly, this is not just UI, it's also an ethical and regulatory concern. And there is no real time system that helps users identify and understand these practices while they're actually interacting with them. And this is exactly what our work is trying to address. I would hand over now the presentation to Mugdha.
Thank you, Diya. I'll take this forward. So to address this particular problem mentioned by Diya, we developed a generative AI-powered browser extension. So what it does is it analyzes the content which is present on the screen in real time. It detects the dark patterns, it classifies them, and then it highlights them specifically directly to the user. So with simple explanation. So the idea is not just detection, but it is also making manipulation visible to the users at the moment it is happening. So, yeah, this is our research methodology. The system extracts the text and the DOM elements from the web page. It sends them to the AI model for classification. These detected patterns are then mapped back to the interface visually and are visually highlighted. At the same time, we also collect user interaction and feedback data. So we conducted a user study with 40 participants across 10 platforms, which allowed us to capture both pattern detection as well as how much the user is aware about that particular pattern present on that site. So this just gives us not just a technical detection, but also behavioral insights on how users respond to this particular pattern. And we proposed a metric called Pattern Vulnerability Index. So I will summarize the key findings that we have. So from our analysis, we detected there were around 351 dark patterns across 61 unique types of patterns present. So user awareness was around 64%, which means that a significant portion of these patterns still go unnoticed. So now what's interesting is the variation across the pattern types. So if you can see the graph, there is a pattern called discount anchoring. It has the lowest awareness, means users are not really aware about what discount anchoring is. And that's why it is a manipulative design. So the key takeaway here will be the most deceptive patterns are often least recognized by the users. And our key contribution, the pattern vulnerability index. So to measure beyond just detection, we introduced this index. So this combines three factors, which is frequency, user awareness, and session spread into a single risk score. So this allows us to identify the patterns that are not just common, but also impactful and overlooked. So we categorize these patterns into risk level, which is high, medium, critical, and low. And as you can see from the graph here, 40% fall into high and critical risk categories. So this gives us a way to move from detection to prioritization of harmful patterns. And we understand which of these patterns are at the most risk and which are unnoticed by the users. And we also, furthermore, we applied clustering to understand how these patterns appear in real time. So these patterns are not isolated, they appear together in clusters. So for example, during checkout, users may encounter bundling, hidden costs, and force action together. Similarly, as you can see in our presentation, there were two other clusters that we were able to find, which is force environment and continuity are combined. The stacking of multiple manipulative strategies increases the cognitive load on the users and makes them more vulnerable to falling into their traps. Next slide, please. Yeah. So I'll just talk about the like every study, there are some limitations. So our sample size is relatively small, and the primarily consists of students, and we focused on a limited number of platforms. Also, the system heavily depends on the performance of the AI model, which was used for detection. So going forward, this work, what we aim to do is we want to extend this by scaling it to a larger and more diverse user group, not just students and engineering students. We want to expand it to mobile platforms and integrate it with real-time user alerts and directly into browser experiences. There is also a potential to align such systems with regulatory framework to help in identify and mitigate these deceptive practices at scale. To conclude, our work demonstrates that dark patterns are both pervasive and often overlooked across digital platforms. So we propose an integrated framework that not only detects these patterns in real time, but also measures the user awareness and behavioral response. By introducing the Pattern Vulnerability Index, we also provide a quantitative way to assess and prioritize high-risk patterns. Through clustering, we identify the context where these manipulations are most likely to occur. So overall, this work currently moves beyond just detection and towards actionable insights to ensure that there is data-driven intervention for more transparent and ethical UI design. So ultimately, our goal is to increase user awareness, support the need for stronger regulations against dark patterns, and promote more ethical UI design. We need to start this conversation that enforces like a ethical UI design for these platforms. For more information, you can check the particular website present here. So you can read about dark patterns and what are the current scenarios and what are the current legal actions that are going on in this particular domain. So yeah, thank you. I will open the floor now for questions.
All right. Is my voice audible?
Yes.
Very interesting topic.
Thank
I
you.
think you are from Pune, right?
Yes.
Okay, so just one question. But you have taken an example of T-shirt related to dollar part rather than rupees of India. So maybe you're trying to deceive us related to dark paper.
No, actually, we did not wanted to point out any other particular e-commerce platforms, so that we just chose a generic example. So we know there are dark patterns across all e-commerce platforms, but even in our research paper, we are not specifically pointing direct fingers at anything. So that's why
Fine.
we chose a
Maybe
generic.
in future, probably just to strengthen your result, you need to show some discussion related to result part. Because
Okay.
right now you have suggested a framework only.
Right.
Right? So just to foolproof your result, you need to go for some graphs and so.
Okay, done.
Fine.
Yes.
Thank you.
Yes, thank you.
Thank you so much, ma'am, for your presentation. Now I'd like to call upon the next presenter, Amina Abdo ma'am, to present her paper titled An Ensemble Learning Approach to Cardiac Catheterization. Ma'am, you may start your presentation now.
Okay. Hi, everyone. Can you listen me?
Yes, ma'am, you're audible. You can start sharing your screen and start presenting.
Okay. Can you listen me? Hi.
Yes, ma'am, you are audible.
Gayatri ma'am, maybe we can take some another one first. Because this is the third time probably she's facing this.
You can share my screen. Can you see my screen now?
Yes, ma'am, it's visible. You can start.
Ma'am, go ahead because you need to do fast.
Can I start now or no?
Yes, ma'am, you can start.
Hi everyone. I'm Amina from Benghazi. I'm from University of Benghazi. Today I want to present a paper titled on simple learning approach to categorization. CBD is diluting global causes of morbidity and mortality. Cardiac categorization is a feature for diagnosis and treatment, but carries risk. The problem over than 19% of patients in Benghazi at heart disease center undergo this procedure and require careful post-operative monitoring. So my object to develop a binary classifier to predict which patients need specialized follow-up monitoring after categorization. More studies have been presented in this in this problem, like Joe's in 2024 have been used logistic regression and R, and the accuracy was 79%. In 2025, the author have been used in R, and the accuracy was 18%. Here in my paper, we use it as a post ensemble and we reached 91%. This result was very good for me. The limitation existent or automated heart disease diagnosis systems show high barriers in feature selection and evaluation, often relying heavily on sample logistic regression or singular model. Our scientific contribution um, um, transitioning to ensemble learning and measure voting, backing, at a post with strict data wanted to achieve state of the art predict accuracy greater than 91% and precision greater than 98%. Can you see this figure?
Yes, ma'am. You can continue. Go ahead.
Okay. This figure shows our proposal in my paper. As usual, the first step, data collection and preparation. First, we collect the data from the center in Benghazi, and we prepare the data using various of techniques to smooth data and clean the data. And we to prepare the next step to select features from the data. Then the next step, the data segmentation and the classification model contribution. We use ensemble learning. We use sample learning and tuning the hyperparameters like okay. And simple learning like LR and decision tree and CNN. Okay. The data segmented to training data and testing data. So, the next step, evaluation and the system. Data set clinical report of 814 patients from Benghazi Heart Disease Center and data predicting 80% training and equal 651 and 20% testing. Feature selection used logistic calculation and to identify 11 critical features: sample age, gender, smoking, HTM, and TM. Individual model. We are the logistic regression and the kind of neighbor KNN and the Jason Trinity. Ensemble technique, majority voting, contains output from multiply models and packing and at the post our ATO. This slide shows the results and performance. We use WordCave and calculate the AUC to achieve our system. As you like the the key finding at the post highest AUC of 100%, okay, displaying the most accuracy curve, but they are decision tree banking, majority voting, and it had a highly competitive AUC of 88%. The lowest was the K. This slide shows the result and analysis. And here you can see accuracy and version and recall and F1 score. The highest was at the post technique. And sample method specific at the post consistently outperformed individual models. The proposed ADP models 91% accuracy. And outperform several benchmark from existing literature, which range from 77% to 86%. The high version scores 98% to ensure reliable identification of patients requiring monitoring. The conclusion in sample techniques, especially the post consistently advanced single model approaches in predicting complex cardiovascular trial outcomes. And the secondary takeaway, logistic regression remains a robust computational high uniterative, proving that sample preference are high effective when paired with rigorously one including data. Our research proves that in sample learning lead by the most robust path for predicting captivate monitoring needs. While we achieve high accuracy today, our future goal is to integrate these models into real-time clinical and the support to directly support doctors in Benghazi and the thank you.
Thank you for your presentation, ma'am. Sir, do you have any questions?
All right, no questions. Thank you.
Okay. Thank you, ma'am, for presenting. Now I'd like to
Thank
call
you.
upon our next presenter, Sai Jagnaseni Rana, ma'am, to present her paper titled An EOK Replenishment Policy with Waning Deterioration, Stock Sensitive Demand and Money Inflation. Ma'am, you may start presenting now.
Ma'am, my screen is visible. Hello.
Yes, ma'am, your screen is visible. You can start presenting.
Okay, madam. Good afternoon, everyone. My name is Sai Jagnaseni Rana. So today I am going to represent my paper title is an EOQ replacement policy with varying deterioration, stock sensitivity, demand, and money inflation. These are my contents. So the objective of my paper is, in the present paper, a model on an EOQ policy for deteriorated inventory items with stock, sensitive, demand, pattern under influence when the deterioration rate is considered to be linear function of time. So finally, here we take some differential equation and solve this equation and found a result. And by using this equation as result, we uh, we solve some numerical examples as well as its post optimal analysis for theoretical model. It's presented to illustrate the proposed our work. These are our notations which we use in our paper. So in the assumption part, the proposed work validates only one type of item. The items of the proposed inventory system allows or follows a time varying duration. The demand pattern for the item in stock sensitive positive backlog stock this from form is allowed to occur in the system. So finally, the average cost function of the system is expressed as the quotient of the sum of all system costs to its cycle length. So the mathematical model of the paper is, here we take a minimize the average total cost of the described inventory model. So in the beginning, a lot size of IMAX unit of item enter into this inventory system. The inventory level dimensions only because of the stock dependent demand in the interval between 0 to TD. And the entire inventory system repeats like the above, and the graphical representation is given here. So here we take a iteration rate, that is theta equal to theta t, theta of t equal to theta t. First, theta is lie between the number 0 to 1, and stock dependent demand pattern dt is equal to a plus bit when I of t is greater than 0 and a when I of t is less than equal to 0. So likewise, we solve this problem. And here we take some assumption for our proposed work. Need to calculate several inventory components or parameter during the cycle, such as order cost, that is OC, holding cost, and iteration cost, shortages cost, opportunity cost, and purchases cost, which is stated as follows. So our order cost is C0, that is C of 0, and holding cost is U. And the holding cost of CH of the proposed model 0 to TB is obtained by CH equal to H to this formula, and the deterioration cost is CD, which is described in this here.
I think you can directly shift to the result part. It's fine.
Okay, sir. Okay. So here our here we get the result, that is the first order partial derivative for the total cost function is this much, that is equation is 18 and the equation is 19. And here the second order partial derivative of this is checking for the sufficient condition is given to us, and the appendices are given here in the A and B and C. And we take some algorithm here. So in step 1, we calculate the TB and capital T from the simultaneous nonlinear equation, and similarly we follow the step 2. So our so so, so this is our conclusion as well as our future work. Here the demand pattern in this policy can be generalized in terms of time, price, or stock dependent demand pattern and stochastic demand patterns. The restriction of time varying iteration can also be relaxed to adopt several variable distribution iteration rate. These are my references. Thank you.
Fine. So I think you've just gone for the number of mathematical models. What about the
Yes, sir.
result part? I don't think so you get the
Yes,
result.
sir. Yes, sir.
Result. What about the accuracy part of a stock prediction?
Yes, sir. One second.
Fine. That's fine. Maybe you can, if it's just a suggestion, maybe you can keep it in a slide next time. Thank you.
Okay, sir.
Thank you, ma'am, for your presentation. With that, all our presentations for this session have come to an end, and I would like to move towards the closing remarks. I would like to sincerely thank all our authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative enough for all of us. We, on behalf of the whole team, thank you all for the support during this 11th version and all the previous 10 versions of the conference, and we'll be happy to have you in the 12th version in 2027 as well. All the presenters would be getting the digital certificates through email within 2 working days, and the publication will be live within 7 to 8 months. Kindly cooperate with the team of ICTIS 2026. Lastly, I would like to thank our session chair, Dr. Bimal Patel, for chairing this session. Here is a token of appreciation to the chair on behalf of Team ICTIS 2026 and Global Knowledge Research Foundation and partners. Thank you so much, sir, for your valuable presence.
Thank you. Thank you so much.
Before finally ending the session, I kindly request you all to switch on your cameras for a quick snapshot. Can you all please on your cameras? Okay, thank you so much, everyone. I'd like to end this session. You all may now leave the session. Thank you.